Study in this video how to apply the basic rules of differentiation in order to find the instantaneous rate of change of temperature, velocity, chemical reactions, or how to find the derivatives applying the basic rules of differentiation. Now, the first rule of differentiation is termed as the constant rule. So the constant rule says that the derivative of any constant means any number, which this thing can be expressed as C prime also. So the derivative of any number is 0, which means if I am asking you to take the derivative of 2, so the derivative of 2 is 0. Derivative of 0.5 is also 0 because it is a number. Derivative of 1 over 3, it is also a number. So the derivative is 0. The derivative of square root of 7, it is also a number. So answer is 0. Derivative of pi is also a constant. So the answer is 0. Which means that whatever the constant you are writing, its derivative is equal to 0. Now rule number 2 says that the derivative of x is 1. X means x, which means the coefficient is 1, the power is 1. So the answer or the derivative is 1. The third rule says that the derivative of Cx, that means a constant, is multiplying with a function. The answer is C, that is a constant, and the derivative of x is 1. So C times 1 is C, which means the derivative of a constant multiplied by x, the answer is the constant. And if you want to understand that how, so we apply here the properties of derivatives, which are almost same as the properties of the limits, that when a constant is multiplying with a function, we write the constant before the derivative and we take the derivative of only function. So in this way you get to C times 1, which is C. The rule says that there is a constant multiple rule. Constant multiple rules, in other words, can be written as if derivative of a constant times any function is written. So this is the general rule, which is called constant multiple rule. Then you can write the constant before the derivative and only take the derivative of the function. So either write d by dx of fx or I can write f prime of x. So have an example. Let's example if I have the derivative of x is, you said, 1. Okay. So the derivative of ax is equals to what? A times 1, which is directly a. So what is the derivative of 2x? 2, correct. And what is the derivative of 3x? Of course, it will be 3. Now, any kind of number, what is the derivative of square root 5 and x? So, it will be square root of 5 only. What is the derivative of 1 over 8x? So, the derivative of 1 over 8x is 1 over 8. What is the derivative of 0.75x? So the derivative is 0.75. So any number multiplying by x, the derivative is the coefficient. It means the derivative is its number. There is another rule that is known as the power rule of differentiation. It means x to the power n. Any x with a power, some power as a constant. Then what you will do? You have to bring the n in the shoulder, that means it is n. Write this variable x as it is and from the power always subtract 1. So let's apply by using a number like x to the power 7. So how to take the derivative of x to the power 7? Bring the 7 before the x. Write this x as it is, and from the power you have to subtract 1. So the power will become 6. Now let's check x to the power 16. So if you have x to the power 16, we bring the 16 in the shoulder, we write the x as it is, and from the 16 we subtract 1, so it will gives you 15. So now if you have x to the power half, what will you do in this case? Of course, you will bring the half before the x, so you will write 1 over 2 x, and then from the power, whatever kind of the power is, you subtract 1. That means half minus 1, which gives us negative half. Let's take one more example, x to the power 0.7. So what you will do, you bring this 0.7 in the shoulder, then you write the x as it is, and then from the 0.7 we always subtract 1, because in the formula it is said to subtract only negative 1. So the answer is negative 0.3. Now, same question, but if I am saying that if the question is written in this way, 1 over x, and you are asked to take the derivative of this thing. Now, what have you seen? That this is the rational function, and so far we have not studied any other formula other than constant, constant multiple, or power rule. So how can you apply these three rules and you can solve this question? So remember, we cannot write that one which is in the numerator and take the derivative in the denominator and this will be your answer. No, this way is wrong. Why? Because this is not the way how the formula is explaining. In the formula, x is in the numerator and in the denominator is 1, that means a constant. So what you will do in this case, the first of all, bring the x on the top. It means shift the x and bring it up, so you will get x. And here the power is 1. When you will bring it up, it will become negative 1. Now take the derivative of this thing, because this x to the power negative 1 can be dealt according to the power rule of differentiation. And do the same way. Bring the negative 1 in the shoulder, write the x as it is, and from the power we only subtract 1. So negative 1 will gives you negative 2. Let's do one more example. What if I have 1 over x to the power 3 and I ask you to take the derivative? So what you will do first, bring the x to the power 3 on the top, means rearrange it. So you will get x to the power negative 3 and now take the derivative. Same way apply power rule. So bring the negative 3 in the shoulder, write it beside x, write down the x, and after that one, what you have to do, subtract 1 from the power. Negative 3, negative 1 will gives you negative 4. Now, let's check one more thing. One more thing says that what if I have square root of x to the power 2 is written, or x to the power 3 is written, for example. So how can I use the power x to the power n? So the formula I have studied only about the power rule. I haven't studied any different rule, and I want to make this situation applicable for this formula. So what will I do? Of course, I cannot write square root as it is and take the derivative of inside thing, that is 3x squared. No, this is the wrong way. Why? Because in the formula there is no square root written. So what you have to do, write or rearrange it. How? You know that the value of square root is 1 over 2 as a power, right? Now, if you have something x to the power 3, so we always write power in over out. Now out means the index. This is your out. So if nothing is written, it means understood that you have here index 2. So it will become as x to the power, in over out means 3 over 2. So you can change x to the x cube with under the radical sign. You can write it as x to the power 3 over 2. And now it is a normal situation. So you can take the derivative. How? Bring this 3 by 2 before the x, that is 3 over 2. Write the x as it is, and from the power there is only 1 will be subtracted. So you will get 3 by 2 minus 1, it will be 1 over 2. Take one more example. For example, if it is only square root of x is written, what you will do in this condition? First of all, write it in the proper way, that is x to the power half. Now take the derivative of this situation. How? Bring the power in the shoulder, that is half. Write the x as it is, and now from the power subtract 1, that will gives you negative half. Now understand that how can we use the power rule to solve different kind of the questions, but make sure that you have an x in the numerator, not in the denominator, and it should be out of any kind of radical sign. Now what if, how can we apply the constant multiple rule? How can we apply the constant multiple rules to solve our normal questions? Let's see here. You know that the derivative of x is 1. So what is the derivative of 6x? It will be 6. What is the derivative of 7x? It is 7. We studied this thing in previous slides. But what if I have 7x square? So again here I can apply the constant multiple rule. It means the c is the 7 as it is right because it is a constant, and take the derivative of x square by using the power rule. It means bring the 2 in the shoulder, write the x, and from the power minus 1, so you will get 2x. Now 7 times 2, you will get 14x. Now if we avoid all these all steps and we want to do 7x square in the direct way, the derivative, so what we will do, we will multiply the power with the coefficient. You have to multiply the power with the coefficient 7x squared. So 7 times 2, it gives you 14. Write the variable as it is, and from the power minus 1, so 14x, which is same as the previous one. Let's practice few more questions. How can we solve square root of, how can we solve 9x cube? Okay, take the derivative of 9x cube, multiply the power with the coefficient. 9 times 3 gives you 27. Write the x as it is, and from the power subtract 1, which gives you 2. So what will happen if you have half x to the power 2? Take the derivative. The only thing you have to do is multiply 2 times half. It will gives you 1. Yani you are multiplying only. So 2 times half gives you 1 x, and then 2 minus 1 will gives you power 1. And we don't write the power 1. Now what will happen if you have 0.2x to the power 3? So again multiply the 3 with 0.2. You will get 0.6 x, and from the power minus 1, that will gives you 2. So what have we studied so far? We have studied that the derivative of any constant number is 0. The derivative of x is 1. And the derivative of c times x is the coefficient, that is c. And what if we have the power rule? We will bring it in the shoulder, the power, we write the variable, and from the power we minus 1. if we have something x yani under the square root x and some power, let's suppose 7, we cannot take the derivative until we remove this radical sign. So we will write x to the power, it can be written as 7 over 2. And if we take the derivative, bring the power in the shoulder, that is 7 over 2x. Then from the power minus 1, it will gives you 5 over 2. Similarly, last thing we studied that if you have 1 over x to the power 6, for example, you cannot take the derivative if something is in the denominator. So bring the function in the numerator. It will become x to the power negative 6. And now take the derivative using the basic rule. You will bring the negative 6 before the x, write the x, then from the power subtract 1, you will get negative 7. So these are the basic rules of differentiation which we can apply.